Happy Friday and welcome. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to wrap up section 10.4, and tonight's assignment or over the weekend is to finish up 10.4 to do the chapter review. On Monday, we will review for a test on Tuesday. All right, so we've got some questions from people that emailed me. So we'll start with, this is section 10.2. Part 2, number 3, as we see on the left side of the screen in WebAssign. A huge suspended LED screen is the centerpiece of the place, a popular mall in Beijing, China. Find the length and width of a similar rectangular screen. So we're dealing with a rectangle. We've got the length and the width. It says find the length and width of a similar rectangular screen if the length is 10 meters more than 5 times its width. So the length is being compared to the width. So we'll start with the width being x. The length is 10 meters more than 5 times the width. So we've got 10 more than 5x. Okay. We also know that the area, the viewable area, is 8,400 square meters. So using the formula, the area equals the length times width of a rectangle, we get 8,400 equals the quantity 5x plus 10 times the quantity x, which gives us 8,400 equals 5x squared plus 10x. You can subtract 8,400 from both sides of the equation, and we get 0 equals 5x squared plus 10x minus 8,400. But each of these numbers is divisible by 5, so I can reduce this down, divide by 5 each term all the way across. 0 divided by 5 is 0. 5 divided by 5 is 1. 1 times x squared is x squared. 10 over 5 is 2, so we get plus 2x minus, let's see, 8,400 divided by 5. 8,400 divided by 5 is 1,680. Okay, so now we've got a quadratic or second degree equation in standard form, and it's been reduced. So we've got A is 1, B is 2, and C is negative 1,680. So using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now continuing to simplify, x equals negative 2 plus or minus the square root of 2 squared is 4. Then we've got minus 4 times 1, which would be negative 4 times negative 1,680 gives us a positive 6,720 all over 2. So x equals negative 2 plus or minus, well, 6,720 plus 4 is 6,724, again all over 2. Now let's see if that's a perfect square. We'll take the square root of 6,724. It comes out to 82. Nice. All over 2. So we've got x equals negative 2 plus 82 all over 2, which is 80 over 2, which is 40, or x equals negative 2 minus 82 over 2, which is negative 84 over 2, which is negative 42. So x equals 40 or x equals negative 42. However, we're dealing with a width and a length. Those are distances. They can't be negative. So even though negative 42 is a solution to this equation, it doesn't fit the actual problem. So x equals 40. So this would be 40 meters, and the length would be 5 times 40, which is 200, plus 10 would be 210 meters. So the length is 210 meters, the width is 40 meters. All right, let's take a look at problem number 4 in that same section. So again, this is section 10.2, part 2, number 4. It says, a large city in the ancient world was square-shaped. All right, so we're dealing with a square. Measured in miles, the area numerically exceeds its perimeter by about 126. Find its dimensions round to the nearest tenth. Now, the fact that it says round to the nearest tenth is kind of a clue that numbers aren't going to come out nicely, but we can deal with that. We've got a calculator. All righty. So let's see. We need to deal with its area and its perimeter. Since it's a square, let's call the length of each side x. So the area would be x times x, or x squared. The perimeter would be 4x all the way around it. It says its area exceeds its perimeter by about 126. So x squared exceeds the perimeter by how much? 126. So if we add 126 to the perimeter, we get an equation equals. Now let's take that equation and put it in standard form. We'll subtract 4x from both sides and subtract 126 from both sides. So now we get the following equation: x squared minus 4x minus 126 equals 0. So we have a quadratic or second degree equation in standard form. A is 1, B is negative 4, and C is negative 126. X equals negative B plus or minus the square root of B squared minus 4, oops, I forgot to put the 1 there, 4AC all over 2A. Continuing to simplify, x equals 4 plus or minus the square root of negative 4, the quantity squared is 16. Then we've got minus 4 times 1, which is minus 4, or negative 4 times negative 126, which is a positive 504. All of that divided by 2. X equals 4 plus or minus the square root of 504 plus 16 is 520, all divided by 2. Now, I'm pretty convinced that 520 is not a perfect square, but I'm just going to check. So I'm going to take the square root of 520. Sure enough, it's 22.8, blah, blah, blah. It's not a perfect square. So I'm going to look at both possible solutions. Okay, so the first one, parentheses, 4 plus the square root of 520, close up the radical, close up the entire numerator, divided by 2, and I get 13.4, let's see, 13.40175425, but it said round to the nearest tenth. That would be the 4. The next place over would round down, so 13.4. Then taking the negative, I get negative 9.40175. The 4 is in the 10th place, the 0 rounds down, so negative 9.4. However, once again, we're dealing with a distance, so the negative doesn't work. And the units were miles. Now, here's what's confusing. It says right off the bat that it's a square. So that means the length and the width are going to be the same. But then it labels it as smaller value and larger value. So don't be confused by that. To me, that's just poor wording. In fact, each of them is 13.4 miles. All right, we're going to stop that for a second. And let me bring up another person's questions. So let's see here. Okay. Got that. 10.4. Number 35. Okay. All right. And so now it says, suppose you are a police patrol officer and you have a 304-foot long roll of yellow do not cross barricade tape to seal off an automobile accident as shown in the illustration. What dimensions should be used to seal off the maximum rectangular area around a collision? All right, this question actually gets into today's assignment, but I'm going to go ahead and do it, and we'll talk in terms of what's coming up today. So we have, let's see, this is from 10.4, problem number 35. We have this rectangle that's made out of yellow do not cross tape. And we know that the entire piece of tape, so the perimeter, is 304 feet. Okay. It says, what dimension should you use to seal off the maximum rectangular area around the collision? Well, if the entire thing is 304 feet, if we were to cut it in half and just consider half of it, that together would be what, 152 feet. All right. So this represents the two sides. Okay. So we've got this side and this side. Okay. These together equal 152 feet, half of the entire rectangle. If I call this piece X, the smaller piece, and I tear it away, what do I have left? Well, I had 152 feet. I took away X, so the piece that's left is 152 minus X. All right. Now, we're trying to maximize the area. The area would be the length times the width. So the area would be 152 minus X times X squared. The area would be, what is that? Oops, not times X squared, times X, my bad, which would be 152X and then minus X squared. I'm going to write this as a function, and I'm going to put it in descending powers. Now, this opens up a whole can of worms about today's lesson. This problem is not in the form that we looked at yesterday, which was y equals a times x minus h squared plus k. Instead, it's in the form y equals ax squared plus bx plus c. The a here is the same a as it is there. So if a is positive, it opens up. If a is negative, it opens down. Well, a is negative. So what we're going to get is a parabola that opens downwards. Okay. Now, the x value represents that dimension, and the y value, or the a of x value, represents the area. So at the top of the parabola, at the vertex, my ordered pair is a comma a of x. That would be the x value that produces the maximum area, which is what we're trying to achieve. So basically, I need to find the vertex of this parabola. Now, this form, we have to use different formulas to get the vertex and the axis of symmetry. When an equation is in this form, the axis of symmetry is at x equals negative b over 2a. And the vertex is at that x value, and then plugging that back into the function. So it'd be a of negative b over 2a. All right, so let's find the vertex. Well, back here, let's rewrite that equation up here. A of x equals negative x squared plus 152x. A is negative 1, and b is 152. We don't need it right now, but c is actually equal to 0. Using x equals negative b over 2a, we get negative 152 over 2 times negative 1, negative 152 over negative 2. Negative divided by negative is positive. 152 divided by 2 is 304. I've done something. Oh, it's not 304. You know what I did? I multiplied it. I thought that's way too big. Okay, hang on. Apparently it doesn't want to let me delete that. There we go. Okay. How about 152 divided by 2? 76. I like that better. 76. Okay. So if x is 76, then 152 minus x, 152 minus 76 is also 76. So the dimensions are 76, what are we dealing with? Feet by 76 feet. So the x value of the vertex is 76. What's the y value? Well, if we take a of 76, we get negative 76 squared plus 152 times 76. And let's see, negative 76 squared plus 152 times 76. We get 5,776, and that would be square feet. So the dimensions, 76 by 76 feet, the maximum area, 5,776 square feet. Notice again over here it talks about shorter side, longer side, but it ends up that it's a square. This problem didn't tell you that ahead of time, that it was a square, but the dimensions are the same. All right, now, what I want to do next, I'm going to pause the video for just a minute. Okay, we'll start the video up again. So today is another day where no one else showed up. And so because of that, since I've already done this lecture that's going to be coming up and it's on YouTube, rather than just repeating it all for my own edification, I am going to take you to where you can find it. So we're going to go here to YouTube and put in math with, oops, help if I could spell, math with Mayo, and go to the playlist. And if we look at Math 93, fall 2021, come all the way down here. Section 10.4 part 2 is the second half of the 10.4 that we're doing with you folks, as I talked about the other day. Anyway, so if you go to this video and watch it, you'll get all the information that I hinted at back here in the problem I just did. And so there you have it. Have a good weekend. I'll see you on Monday for a review. But again, go to the Math 93 Fall 2021, Section 10.4, Part 2 for today's video lesson. All righty. And so have a good weekend.